Hey guys, today we'll be talking about how to migrate a cron job to MongoDB Realm architecture using triggers and worker functions. Let's get started. The agenda will cover traditional architecture versus serverless architecture, what a cron job is and what are triggers, what is the difference between the batch cron job architecture and trigger based architecture, and we'll be seeing that using some example demos. Let's talk about traditional architecture. Traditional architecture is one where the company's infrastructure team or DevOps team needs to host dedicated servers to be able to deploy the various softwares. Now, the infrastructure team needs to handle all the issues regarding this architecture, which could be first, they have to manually provision these servers. Then they need these servers to be maintained, and the maintenance lies with the development team for the uptime. The networking, connections, integrating each software and databases together is a big task for them. The team needs to see about the scalability of the software, which has to be done manually or using some orchestration tools. These servers are always up and therefore involve a very high cost. Now let's talk about serverless architecture. Serverless architecture is where we do not have to provision or manage any servers. We do not have to have any server administration to check the uptime of these servers. There is unlimited scalability, and we can scale each instance of a serverless function to n number of times as per need. The cost is calculated as per the resources used and not hourly or daily. Each instance of serverless function runs in parallel, and therefore each instance is stateless and independent. It does not interact with other instances. Now let's talk about cron job and what a cron job is. Cron job are commands or scripts that a user needs to schedule to run at a particular date or time, often repeating at the same time every day or every week. These tasks or commands are referred to as cron jobs. Now, these cron jobs are used for automating tasks, for information reporting or administration, and often for maintenance tasks. So these tasks almost always run as batch processing job. And what do I mean by a batch processing job is what we'll see in the next slides. The example could be just to create regular backups or exporting data from your database to a third-party integration for monitoring or archive. What are the cron job types with respect to MongoDB? So there could be three types of cron jobs. One, which processes data within MongoDB at certain intervals of time and dumps the data back into MongoDB. The other is to export data to external services. And the last could be that we are importing data from external services and saving them in our database. So what are MongoDB Realm triggers? Before we go on to that, let's talk about a MongoDB Realm. MongoDB Realm gives us a serverless backend in which there are functions, and each function runs as a serverless function on the serverless architecture provided by MongoDB Realm. It is fully integrated with the database, that is the MongoDB Atlas database, and we do not have to maintain any other connections. They also provide us with triggers. So what triggers are? MongoDB Realm Triggers provides us with three different type of triggers. That is a schedule trigger, a database trigger, and authentication triggers. Schedule triggers are those which run at a specific time every day or whenever you want to schedule those. Database triggers fire upon when there is a change in the data source, that is your database. So whenever there is a find, insert, or update, these triggers would fire and you can capture these triggers. The authentication triggers are something which we'll not be talking about in this talk. So let's see a basic cron job example. What a basic cron job is. Let's suppose that we have a core database and a backup database. So what we want to do is every day we want to copy the users from the core database and create a backup of all the users in the backup database. So as simple, we find all the users and we transfer them into the backup database. Very simple, very native, but it's as easy as it gets. Now let's see a basic example demo in which we create a schedule trigger for backup. Let's hop over to the Atlas page in which we have already created a cluster. Let's go over to the Realm tab. In this Realm tab, we can create a new application that connects to the same cluster. Right now, I've already created a sample application. That's the demo application. When we go inside the demo application, we can go into the triggers and create a new trigger. When creating a new trigger, we can create the three types of triggers. Right now, we'll be creating a schedule trigger. We'll be creating a scheduled backup job trigger, for example. And in this schedule type, it can be either basic or advanced. So this basic means when this schedule trigger should be scheduled at. So we can repeat this every minute, every hour, and so on in the basic view, or else we can head over to the advanced view in which we can actually put in a cron schedule as per the Linux, and it will get scheduled at that time. So let's schedule this at 00 hours of GMT so that it does not interfere when we are creating this trigger. So with this configuration, it will run at 00 GMT time every day, correct? Now, to create this trigger, we need a function that will consume this trigger that it will fire at the scheduled time. Right now, we do not have any functions, so let's create one function. We'll name this function as scheduled job. And what the scheduled job will do is we'll just create a backup from the core collection users to the backup collection. So what this function will do is just to create a backup from the core database users collection to the backup database users collection. What we'll do is first we'll create the connection to the MongoDB Atlas cluster we had made. So const MongoDB Atlas equals to context.services.get MongoDB Atlas. Now with this connection, we can create our two database connections. One can be the core users equals to MongoDB Atlas.db core database, and the collection we'll be using is the users collection. Let's create another backup users connection .db backup .collection users. Correct? Now, what we'll do is we'll find all the users in the core database, regardless of they have been backed up or not. So this is because we want to see, this is because we want to copy the users from the core to the backup users again and again to show that every time the job is scheduled, it will copy all the users from the first database to the second database. And therefore, we also need to project the underscore ID so that it can insert multiple copies of the same documents. When we are finding these documents, we'll convert these first to an array, and then the result array or the result list will be inserted into the backup users. Now let's check if this list is not empty so that it does not give us any error. Insert many result list. Correct? It is as simple as this. So let's save this. Once we save this, we can see that a trigger has been created, that is scheduled job. And for this trigger, we have created a function to consume the trigger. that is the scheduled job function. Correct? Now let's deploy these changes so that we can see them in action. Once deployed, let's head back to the Atlas clusters, go into the collections to see what data is there in our cluster right now. So as we can see, our cluster does not have any database or collection. So to populate the core database with some users, I have written a script that will insert 500 users to the core database users collection. Once we run this, we come back here, we refresh our collections, and we can see that the users collection is in the database core, and there are 500 documents of the same. Each user has a name, email, username, and age. Correct? Now, let's go back to our MongoDB Realm. In MongoDB Realm, when I go back to my function, and as it is now scheduled at 00 hours GMT, let's not wait and let's just manually trigger this function once to see what's going on. So once we run this function, you can see that it has completed. Let's go back to the collections database. Let's refresh this. And we can see that the backup users collection has been created with exactly 500 documents. Correct? Let's head back to the MongoDB realm and into the triggers. Now let's change the schedule of this trigger to run at every minute, so that every minute it copies the 500 documents again and again to the backup collection. Let's save this. And to see if this has been completed or not, what we can do is we can actually head over to the logs section and we can wait for a minute to see if this has been done or not. Now we can see that a minute has been passed and we can refresh this page and we see that the scheduled trigger has been fired. Now, once we go back to the database, we can refresh this and see that the backup users has a total of 1,500 documents because the trigger was executed for every minute at 9:22 and at 9:23. Correct? Now let's head back to the slides. Now let's talk about a bit more complex cron job. Let's see what a batch cron job architecture is. So in this batch cron job architecture, what we are doing is we are connecting to the users collection. Then we are finding all the elements in the users collection. And for each element, we are trying to execute the task 1. Then we are trying to execute task 2. And once that completes, we are trying to update the username and setting the flag done as true. So what we are basically doing is there is a master executing function. That function, for every entity it loops, and for every entity it performs the task 1, 2, 3 up to task n, and therefore executes the whole flow. So this master function executes it for the entity first, the second entity, the third entity, up till the nth entity, and then himself exits out. So let's see the batch cron job example. What we'll be doing is we'll be creating a password hash for each new user. Let's head back to MongoDB Realm page. First, we'll just disable the schedule trigger so that it does not run every minute. We'll edit this trigger. We'll go over here. We'll just disable it and we will save it. Once saved, let's just deploy these changes. Now, As you have seen, a schedule trigger consumes a function that is scheduled job. We can create another function that the scheduled function trigger can execute. Let's create a new function. Now the function name should can be master password function, and every trigger has to have the function authentication as system, so that it runs in a system mode and not as a user mode. This function, let's save this. Okay, so what this function will do, exactly like what we had done before, instead of copying the users, what we'll be doing is we'll be using a third-party API to actually hash a random password and then set that password back to the user. So whenever a new user signs up, what will happen is every day this job will actually find all those new users and set a default password and hash them and keep them in the database. So what we'll do is first we'll create a connection to the users collection, that is context.services.get MongoDB atlas.db same database core dot collection users, right? And what we'll be doing is we'll be finding all the users that are new in the system. That means that does not have the password hash key set in them. What we'll be doing is we'll be finding all these users and setting this password hash key into them. Okay, so once we found this, we'll convert these into an array, and for each element in array we will iterate. So once we get the users list, we'll iterate over this users list for each user, and for each user what we'll be doing is creating another function that will actually call the API and set the password hash for that user. So we'll be calling another function that we'll be creating right now, and we can name that as set password hash, and we'll be passing in the user object to that function. So what we are doing is we are trying to find all those users who does not have the password hash set in them, and for all those users we'll iterate one by one and call the set password hash function, which will actually hash a random password and set it to the user. Correct? Let's save this. Let's head back to functions and let's create another function, set password hash. Now this set password hash will also be a system running function, as this will run in the background. Let's save this. Let's remove the argument and the default code. Now what this set password hash will do is basically will accept a user object, correct? Now from this user object, it will create a random user password that will be comprising of the user's username and the user's age. So for each user, these two fields will be used to create a user password, that is the default or the first password set for that user. Now, what we'll do is we'll call a third-party API. Over here, what we'll be using the Hashify API. Now, what we'll be doing is we'll be using a third-party API to hash this user password. Over here, what we'll be doing is we'll be making a post request to a third-party service, that is the a Hashify API service, which will return us the hashed password, that the password for the password we have created right now. So the URL will be https://api.hashify.net/hash. We can use any type of hashing algorithm. Let's use SHA 512, and the digest can be of base 64. Correct? You can see the API for other various parameters also. So let's pass the user password we have created above as the body of this request. Now, once this HTTP call is made, it returns us a response creating the digest. Let's first encode the body and get and retrieve the response body from the response. So the response body equals to ejson.parse resp.body.text. Correct? And in this response body, we will be actually having the digest in the digest key. Okay. So what we have done is we have created a user password comprising of the user's username and age. We have sent that user password over to the api.hashify.net, and in the response body we are having a digest key, that is the hashed value for this user password. So we'll be setting this password back to the users document in the users collection. So let's just again connect to the users collection, that is context.services.get MongoDB atlas.db core.collection users. Now this user will update this document of the user with the new hex digest users dot update one, and we'll be searching the user by its username and setting the password hash as the response body digest key. Correct? So let's save this and head back to our master function. So this master function, it will iterate over the users, and for each user, try to set the password hash for that user. Let's deploy these changes first. Once done, what we can see is right now in our users collection, in the core users collection, no document has the password hash set. So let's go back. Let's manually run this master function. And what we can see is for 500 documents, it will take a bit of time. So these users, when it is iterating over each, this list, when it is iterating over each user, it is trying to set a password for each of those 500 users right now. Now, this is a type of batch architecture in where we are actually fetching a huge amount of data and then doing or processing that data and doing some task. So let's wait for it to finish first. See, as we have finished, it took around 33 seconds to run for 500 users. Now imagine instead of 500 users, you have 5,000, 50,000, or 500,000 users. Now what will happen at that time? And right now we are only having one API call per user. So what if you have 10 tasks or 50 tasks per user? So this time will be exponential in the number of users we have. And what Stitch does, what Realm does is it has a 90 seconds timeout for each function to run. So let's talk about that a bit later. Let's come here to the data. Let's refresh this. And as we can see, each user has a different password hash that has been set and a password has been generated for them. Correct? Now, let's head back first to the presentation. So, what is a batch cron job architecture? So, the batch cron job architecture, the master orchestrates the execution, as we have seen. There is a single function that will iterate over the different entities, and for each entity, it will trigger the pipeline. It loops on every entity found. That is correct. Now, this master function waits for every flow to complete before exiting itself. So the master function has to wait for all the 500 users to finish their execution, the whole pipeline for each user, and then the master function can actually quit and complete. Now, this master function has to handle all the errors and exceptions for each entity or user in this case, and it is responsible for each entity. So this is where a bottleneck is. So the bottlenecks of batch architecture can be actually solved by using an event-based system. Now, to create an event-based system, MongoDB gives us change streams, which are native to the MongoDB database. MongoDB change streams are change events that are fired when any changes happens to a database or a collection, and we can see which document has changed, what has changed in that document, and we can capture and respond appropriately. So to use MongoDB change streams, what you have to do is we have to write a lot of code. We have to listen and track those changes on a real time and maintain that code somewhere. Correct? So not using MongoDB change streams natively, what we can do is we can use the trigger-based architecture that the MongoDB Realm provides us. So what is a trigger-based architecture? Database triggers are an abstract and a wrapper around the MongoDB change streams that MongoDB Realm provides us with. These triggers fire automatically and on the data changes that happen to our collections and databases. And for every change in the database, it fires a single trigger. So rather than having changes in batches, we can actually capture these changes in the databases and run the background jobs for each change. What it does is it allows us to have a real-time processing or almost real-time processing. So whenever a trigger fires, we can implement the whole pipeline for that single entity without any delay. This also helps us in distributing the load, because when the batch architecture runs, there is a big load on the system where every resources are used to process the whole batch records. Now, when triggers are fired, each trigger is lightweight because it handles only a single entity and can span over a long period of time and can be used at the exact time when the change has been done in the database. So what is a trigger-based architecture? So trigger-based architecture means that a trigger event has happened for an entity A. For example, a new user has been created. So for that user, a single pipeline gets instantiated in which that pipeline will run the task 1, the task 2, task 3, up to the task n, and then end that single pipeline for that single entity A. Now, each pipeline of or each trigger that we are firing has no relation with the other pipelines or the entities. So over here, we can actually use serverless architecture to actually use these triggers and separate out the business logic for running the pipeline A with the pipeline B, and we can actually save cost and do it on a real-time basis. Now, what does a traditional architecture look like? The traditional architecture is a single child tree structure, as we looked before, that has a single change event that is taking place, and the whole pipeline goes around. Now, these workflows are independent workflows and can run in parallel as they are independent of each other. There is a real-time execution, so there is no delay in implementation as to when the task will be implemented or executed. It can be executed as soon as the trigger fires, and it can complete as soon as possible. Now, these triggers, when deployed on serverless architecture, can make use of usage cost. So the cost is calculated per usage, how much memory you are using, how much execution time you are using, etc., about the system and the billing structure they have defined. And there is no maintenance to see that a system is up and running. We do not have to provision any servers, and we do not have to have an always up server so that it will detect or it will listen to all the changes. So let's see this with a database trigger example. Let's head back to the MongoDB Realm. Over here, what we have done is we have created a master function and a set password hash function, right? So right now we'll create a database trigger. Let's go back to triggers. Let's add a trigger. And right now we'll be adding a database trigger. Let's name this as real-time password set, correct? Now this function, flag event ordering, this means that the triggers or the pipelines will be executed in the order of the event that has occurred. So right now, setting a password for user A does not depend on setting a password for user B. So we can switch this off so that all the tasks can run parallelly and does not have to be sequential in order. So when we are creating this trigger, we can connect this to the MongoDB Atlas. This database trigger will look up the core database and the user's collection in the core database. What it will do is it will monitor for inserts and return us the full document that has been changed or inserted, right? So over here, what we'll be doing is we'll be creating a new function, and we'll name that function real-time master. Now this real-time master, what it is having is it is having a change event. Now this change event, we can actually get, from this change event, we can get the full document that has been inserted equals to change event. And we can just simply call that set password hash function for this single user. So this full document is basically a user that we are inserting, right? Set password hash, and instead of passing the user, we are passing the full document, because the full document is actually the user that we are trying to insert. So let's save this. It is as simple as this. So let's deploy these changes. Now, as we have seen, we can go back to our triggers section, and we have seen that we have created a real-time password set database trigger that will execute whenever we are creating a new user. So right now in our collection, every user has the password hash set for it, correct? So what we'll be doing is we'll be re-executing the Python script. What we'll be doing is we'll be going back over here and re-executing this Python script. So it will delete all the users from the core database and reinsert the 500 fresh users in this core database, which does not have the password hash set in them. So once we run this, we can refresh and we can see that there are 500 documents. So now, as you have seen, we have created new users, but the password hash is already in them. So why is that so? Because once we go back over here to the triggers and we see the logs, we can see for every user, the database trigger has fired and it has been successful in setting the password hash on a real-time basis. So instead of using 30 seconds to set the password hash for 500 users, each user is triggering a different pipeline, and each pipeline is getting completed in 300 milliseconds. Now, what Realm does is it sets a 90 seconds timer for every function, right? So if master function in a batch cron job architecture waits for all the childs to complete, it can wait up to 90 seconds. But right now over here, each trigger or each individual pipeline can run for 90 seconds, and that has a huge benefit over the batch architecture job. So as we can see on real-time access, every user, the password hash has been already set, and we do not have to wait for any scheduled job to run to set this password hash, correct? Let's go back to our slides. So what are the trigger-based architecture concepts? So there is no sequential restrictions. The entity A pipeline is independent and stateless with respect to entity B pipeline. Each workflow is independent, each single entity responsibility. So that means that each trigger or each pipeline consuming a trigger is responsible for its own entity's data, for each entity's state during that pipeline, and handles its own errors and exceptions that happen. So if pipeline 2 fails, pipeline 1 has no role in handling those errors that pipeline 2 is triggering. So what is the trade-off between batch architecture and trigger-based architecture? So batch architecture we use when we have provisioned servers and we have to maintain the server uptime. Trigger-based architecture is we can use in a serverless architecture. Batch architecture, we can use when we have to maintain the states between the each pipeline. And trigger-based architecture, it does not maintain any state, and we can use it over in circumstances where we do not need to maintain any state to be able to run things in parallel. So batch architecture, it takes longer time to run. The trigger architecture takes much less time to execute. The batch architecture, it does not make system real time. The trigger architecture does. So batch architecture is a passive approach, whereas trigger architecture is actually an active approach. So what is the perks of using MongoDB Realm Triggers? So this was very easy, right? But as you guys have been using cron jobs, you know that you need a server. You need to actually maintain that server. You need to actually have that server running 24/7, and then we have to schedule those jobs on the cron tab, and we have to see that these jobs run or not. But instead of that, we can use the MongoDB Realm triggers, which what we do is, instead of using a traditional architecture, we are trying to use a serverless architecture. Instead of using a batch job, we can use managed change streams that the MongoDB Realm provides us to have real-time integrations. Now, MongoDB Realm is already integrated with the MongoDB Atlas, so you do not need to maintain any other connection to your databases. It has zero maintenance, and you do not have to actually maintain the uptime of your service. It can be scaled to n number of times, as there are n instances that can be created when there are n events. And it is fully customizable, as you have seen, so that you can actually listen for some type of updates. You can filter on the changes that the change streams are providing you. You can actually do anything you want, and it is fully customizable. Thank you. That's all. And have a great day.